Containers are data types which contain a collection of items and allow us to access those elements. Typically, a container is also iterable, meaning that we can use them the same way we used strings in the loops chapter. For example, a grocery list is a container of items we want to buy, and a list of primes is a container of numbers. Written in pseudocode would have the grocery list, that is a list of, for example, ham, eggs, bread, apples. And for primes, we just have a list of numbers. That's pretty much it. So there are many types of containers. Therefore, we can start with arrays. An array is the simplest container type. Arrays are homogeneous. An example, what it means, all elements in an array must have the same type. Arrays are also a constant size, meaning that the amount of elements, or rather the amount of possible elements, must be known at compile time. This means that we call arrays a homogeneous container of a constant length. The array type is declared using the keyword array. Then we have our square brackets, and inside we have length and type, where length is the total capacity of the array, number of elements it can fit, and type is a type of all its elements. The declaration can be omitted if both length and type can be inferred from the past elements. The elements of an array are enclosed inside of square brackets. So let's see. We declare a variable a, and we define that the type of that variable a is an array of 3 elements that are of type integer. So this array will be able to contain only up to 3 elements, up to 3 numbers basically. And then we define assign it the first value. In this case, it will be 5, 7, 9, and it's all within brackets. It's not simple. I like that you don't have to use any other special characters. Dealing with an array, use just brackets. With B, we have basically pretty much the same thing because we passed it a piece of code that basically creates an array of 3 integers. The compiler will assume that, we mean array of 3 integers. So if we provide the values at compile time, it will be just like that. Yeah, although correct, there is no need to declare it like an array A. So yeah, basically if we know that this is the only thing we'll be holding in, there's no point doing that. Too much work. With the next one, with the C equals, and we have just brackets, nothing inside, apparently that throws an error. Neither the length nor the type of the elements can be inferred from this kind of declaration. This produces an error. Exactly, because we tell it that it's an array, but the compiler needs to know how much memory to reserve, and therefore, it doesn't know what kind of type it's going to be holding, nor how many elements there are. In our human brain, we think, it's 0, so do 0, but at that point, what's the point? Compiler doesn't like it. And let's look at D. We declare an array of 7 elements that are strings. So basically 7 strings we can fit in there. Number 3. The correct way to declare an empty array, which will be filled later, is to give its length and type. So we gave it length of 7 and type of string, without providing the values of its element. Array D can contain 7 strings. So we basically create an array that can contain 7 elements. There just isn't something at this point in it. Okay. Since the length of an array has to be known at compile time, this will not work. So we declare a constant m, which is number 3. Then we create a variable n, which contains 5. So if we declare an array A that has length of m, which is a constant, which is known at compile time, this will work. But here in B, we try to use n as length. And even though it's right here in the code, this is declared as let, which means this code is isn't running at compilation time, it's only happening at runtime. Therefore, this will throw an error. Exactly, this produces an error because n is declared using let. Its value is not known at compile time. We can only use values declared with const as length parameter for an array initialization. Okay, so sounds like arrays are very static and efficient because compiler knows as much as you can about what is being held inside. Okay. So arrays, we need to use the word array and square brackets. All right, so let's move on to sequences. Sequences are containers similar to arrays, but their length doesn't have to be known at compile time, and it can change during runtime. We declare only the type of the contained elements with the seq for sequence, again just square brackets and the type inside. Sequences are also homogeneous, as in every element of a sequence has to be of the same type. The elements of a sequence are enclosed between at and the square brackets. Okay, so here we declare a variable e1, which is a type of, its type is sequence of integers. And we create, looks like an empty one. The type of an empty sequence must be declared. Okay, so you can have an empty sequence. You just need to make sure that you define the type, as in what is being held inside. And next example is where we create variable f. Instead of specifying type, we instantly assign a value. In this case, that at will say that it's a sequence, and we have 2 strings inside. And the type of a non-empty sequence can be inferred. In this case, it's a sequence containing strings. Perfect. Less work for us. Less writing. Compiler is smart. Okay, that's straightforward. Another way to initialize an empty sequence is also to call the new sequence procedure. New seq. We'll look more at procedure calls in the next chapter. But for now, just know that it's also a possibility. So we can declare a variable e as a new sequence of type int. And I guess this is just calling procedure. Procedure is like a method or function. So that's pretty straightforward. Providing the type parameter inside the square brackets allows the procedure to know that it shall return a sequence of a certain type. A frequent error is omission of the final parentheses, which must be included. Yeah, I presume that if we would omit them, we would just put the whole function inside a variable, and that wouldn't be very useful, at least in that case. Alrighty. So, we can add new elements to a sequence with the add function, similar to how we did with strings. For this to work, the sequence must be mutable, defined as var, and the elements we're adding must be of the same type as the elements in the sequence. Oh, I really like it. When you think of some other programming languages, that would be, let's say, when you create a list of elements in C#, or when you create an array in JavaScript, even if you declare it as const, it only means that the pointer that points at the value at the whole list can change. You can reassign the whole value, but you could still add elements to it. You need to freeze it in JavaScript world. So here, somehow, the whole thing is being protected with those separate Tuples declarations. So we declare a variable, so those sequences can change. We declare a sequence G contains 2 characters, X and Y. Then we have another sequence that contains also characters, this time 3 of them. So what we can do is call g.add, and we add a z character, adding a new element of the same type character. And we can print it out, and this should print x, y, z, at least a sequence. We'll look at it in a second. And then we have h.add, and we can add g. So we get that sequence, and looks like we can add the whole other sequence to it. And because if you would try to do it in JavaScript, you would end up with an array that holds that number 1, number 2, number 3, and then will be inside of it another separate little list. But because it was said that sequences are homogeneous, that means that compiler knows that it's not possible to put a list inside of a list here. It expects those values. So if we added that G, it checks, is G also of type character? And okay, we're going to put, concatenate them together. So adding another sequence containing the same type. And here we have the results. When we just added Z to G, we ended up with this sequence. And the next sequence, we have the 1, 2, 3, and the contents of the other one. So we suddenly have 6 elements here. I like it. Very simple, very clear. In C# we need to do add range or some other shenanigans. This is simple. I like it. Trying to pass different types to an existing sequence will produce an error. So we have a sequence of integers, and we try to add a float. Of course, we'll throw an error. And if we'll take G, which from here is the sequence of characters, and we try to add a sequence of numbers, it will also be unhappy and just ignore it. Okay, makes sense. Let's continue. Yeah, trying at the float to int is bad, and trying sequence of int to sequence of characters is also bad. Since sequences can vary in length, we need a way to get their length. For this, we can use the len function. Okay, so just like we can call add, we can call the sequence.len. the return length. So this will be 3. And here we added another character. So now another number. So the length suddenly should return 4. And yeah, there we go. Cool. Simple. .len. Indexing and slicing. Indexing allows us to get a specific element from the container by its index. Think of the index as a position inside of the container. Nim, like many other programming languages, has zero-based indexing, meaning that the first element in a container has the index 0. The second has the index 1, etc. If we want to index from the back, this is done by using the, whatever that symbol is named, prefix. The last element, first from the back, has the index of whatever 1. Okay, I like it. I guess it's on purpose that they didn't go with negative numbers. I recall some languages allow you to put negative numbers in an index and that will start counting from the back. But then I can see problems where there was some miscalculations and suddenly it takes in random element from the list because of something. So, okay, this is explicit. The syntax for indexing is you get the container and in square brackets you put an index. So, for example, we have an array because there's no @ symbol before this. We take an array of 5 elements that are all characters. So if we'll do echo j, which is the name of the array, we'll say we want the element 1. So because now we know that it's 0-based, it will be really the second character, so it should return b. 0-based indexing. The element at index 1 is b, exactly. And if we'll go echo j, and we do this thing 1, this should return last element, getting the last element. There we go. That's simple. Okay, pretty much everything clean so far. And I presume, let's try it. Let's grab this code. Let's put it in VS Code. Okay, we'll save it. We run it. And there we go. B and E. So what if we're gonna change it into a sequence instead? We'll put an @ symbol here. Save it. We see that already. VS Code detected it's a sequence. Okay, so we don't need to do anything special to when we're using an array or sequence. We should be able to run it and we'll still get the same result. Great. Okay, that got my curiosity. And this will be 2. Should get D instead. Yes, D, because we get the second from the back. So this is first, this is second. Okay, cool. So let's move on. Slicing allows us to get a series of elements with one call. It uses the same syntax as ranges, introduced in the for loop section. We use the start-stop syntax. Both ends are included in the slice. Using start-stop with the less than syntax, the stop index is not included in the slice. Okay. And the syntax slicing is, again, container, and in the square brackets, we just put that range. Easy enough. So if we'll call echo j, which were those characters, from 0 to 3. So we'll have a character 0, character 1, 2, and character 3. So there should be 4 characters. There we go. A, B, C, D. While if we'll call with this little thing, we will have 0, 1, 2, and 3 will be omitted. There we go. Okay, makes sense. I like it. And this way, this looks like it returns a sequence. Oh, that's very interesting. Both indexing and slicing can be used to assign new values to the existing mutable containers and strings. We'll get there in a second. Let me just check something because, as you remember, J was an array. When we got a range, we got a sequence. I think I know why. Let's try this. Let's try something. So let's keep that sequence J, and we'll say that we're gonna echo from 0 to 3, right? Should be A, B, C, D. We save it, we run it, there we go. It returned a sequence of A, B, C, D. But we started with a sequence. What when we get it back to an array? Save it, run it. We also got a sequence. Okay. So what that suggests to me is that we have the result of slicing, getting a whole range of characters. It doesn't return an array because it's hard to predict what the actual size is. As in, I presume that if I'll do constant max equals 3 and put from 0 to max, it's still all within the compiler. So if I'll run it, in theory, I could expect an array, but no, not in this case. So that means I should be able to just make a variable, something that's not compile time. That's something that's not known during compile time. So let's run it. Yeah, it still allows me. I'll see 2, run it. Yes. Okay, so we know that we can calculate those slices, the ranges during runtime, and no matter if it was compile, known at compilation time or during runtime, we know that we have that. We'll get a sequence returned. So they just said that slicing allows us to get a series of elements with one call. Wait, here. Both indexing and slicing can be used to assign new values to the existing mutable containers and strings. That sounds very interesting. So let's see. We have variable k, and it's an array. So it's known during compilation time. Array of 5 elements, and these are all integers. Then we get create a sequence of 3 characters. And then we have a variable, which is a string. And you can think about a string as basically a sequence of characters, right? This will be a string PWR. It's just written as separate characters. Well, here it's just nice and handy because we use that specific sequence of characters so often that, we call them strings. So we can iterate from 0 to 4. So be our index. We take k as our array, and we get the specific value and specific index, as in, go through each element, and we can assign it a value. In this case, it'll be from 0, so it'll be 0, second will be 7, next will be 14, and so on. And this should assign all the elements. Remember that this is length, but because arrays are indexed from 0, we have 5 elements. Element 0, 1, 2, 3, and 4. We don't have 5 because with 5 that'll be 6 elements. And when we print it out, it should print out a nice thing. So let's see. There you go. Just an array. So we start over an array, and we have an array. We just assigned those values because here we created empty, so there were no values. Okay. Array of length 5 has indexes from 0 to 4. We will assign the value to each element of the array. Great. Now, let's go to L, to our sequence. We take L, index 1, which will be W, and we assign the letter Q. So we should echo the sequence of PQR, sorry. Yes, PQR. Changing the second element, index 1, of a sequence. Great. And then we have our string. It looks like we can use the same way of accessing elements of a string, just like sequences and arrays. This way, we take characters from 8 to 9, so which is 8 and 9, and we assign the letters BA. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8 and 9. So it should be Tom and Barry. There we go, Tom and Barry. Changing characters of a string indexes 0 and 1. Let me try something, because I already have questions, especially with that last one. So we've got that string, and we replaced element 8 and 9 with BA. So we took 2 characters and replaced them with 2 characters. What if I'm going to add 1 extra character? Save it and run it. Look at that. We replaced 2 characters with 3 characters. What if I'm going to select the whole thing? It was 8, 9, 10, 11, 12. So we get from 8 to 12, we'll select the whole Jerry, and we'll say Ben, which would be less characters. Save, run, there we go, Tom and Ben. So when it comes to sequences, we can replace it with different lengths, at least when it comes to strings. What about sequences? Can I take our sequence L and let's say we'll replace character from 1 to 2, which will be W and R. What is going on? With something like, we need to give it 2 characters, right? So how do we do it? We need to add another sequence to it? That's where it becomes less simple. O and D. And when I run it, what will happen when I run it? It replaced it. Pod. It took the W and R and replaced it with OD. Can I add another character? Can I elongate it? Save. Run. Yes, we've got pods. Can I make it shorter? Yes, we can make it shorter too. That is awesome. Okay. So we can use ranges to make something shorter or longer. What if I will just take that, we'll take that index 1, the W, and we assign it O, and then another O. Can I do that? We're taking now sequence of characters for an expected character. Okay, so if we're assigning a single element, it's problematic. So could I do from 1 to 1? Run it. There we go. So we need to use basically a range to be able to do something else than assign a single value. We can replace something more complex with that. Okay, makes sense. Cool. Oh, that already gets me thinking. So what if I'll have can I do something like I will call it range. Oh, that's a word. Oh, selection is from 1 to 2. Can I assign it as a value variable? Yes, it's just not used. Okay, so can I put it here? Selection, save. Yes, I can. So what if I'll make the let's call it selection range. I will create a new variable. Let's say that will be variable selection, and that will hold the actual thing. So say equals, and we do that with L selection range. So now our selection should be of type, should be basically a little sequence from 1 to 2, which will be WR. So we have some kind of code that calculates what our range should be. We have different code that extracts that sequence. And then I guess in a separate step, I can say that, hey, selection, and let's say the first character of that selection is, or let's say that first character gets replaced with the sequence 00, right? So this should suddenly turn from WR to OOR. And now I should be able to say, hey, take that initial sequence L and that selection range, we want to replace it with what we calculated, which is a selection. We modified it. And that should return L. We can get rid of all the other ones. So that should have the same effect. I just want to make sure that actually we can do that in those separate little steps, because that means that we would be able to take those slices as little sequences, pass them around, do modifications on them, and put them back. And I'd say that would be a useful thing. So let's run it. There it goes. It works. That's very exciting. Very, very exciting. At least for me, it's exciting. All right. So continuing, we finished with sequences. Let's go over tuples. Both of the containers we've seen so far have been homogeneous. Tuples, on the other hand, contain heterogeneous data, as in elements of a tuple can be of different types. Similar to arrays, tuples have fixed size. So the elements of a tuple are enclosed inside of parentheses. So here we created variable n, and we created tuple, just parentheses, that's it's a tuple, of 3 values. First one is a string, second one is a number, and the third one is a character. Tuples can contain fields of different types, in this case string, int, and char. And when we print it out, we get this thing. We just don't get just banana 2 and C. We get field 0, field 1, and field 2. We can also name each field in a tuple to distinguish them. This can be used for accessing the elements of the tuple instead of indexing. Oh, before we get there, they said instead of indexing. So we'll take this thing. Let's see if our assumptions are correct. So we have that tuple, and when we echo it, we just get our classic banana. Okay, that makes sense. So, oh, look at that. We actually didn't get the field, the thing that they got. We didn't get this whole thing. We just got this. That's interesting. But what I'm trying to understand is that we can echo 0, and this should access the element 0 of this, because they call it a container, right? Just like sequence. If we'll do 1, we should get number 2. So let's try 1. We got number 2. Perfect. Okay, so they just act as those. But can I do for whatever value in n echo value? Can I do that? Type mismatch. Expected 1, iterator. Okay, so I guess we cannot iterate over the tuple. Okay, makes sense, because at this point compiler wouldn't be sure what the value is. Alrighty, so we can also name each field in a tuple to distinguish them. So we can specify that the variable O, we create a tuple because we have parentheses, and we say name is banana, weight is 2, and rating is C. So instead of accessing in this case, assigning the index 1, which will be, I presume, weight, right? Change the value of the field by using the field's index. We could do O.name, so we had dot notation for accessing those elements now that they're named. No square brackets, no weird shenanigans like in JavaScript. This is more like in a JavaScript object where we can just do .name and a value, Apple, changing the value of a field by using the field's name. And look how they made those examples. Whenever they were assigning weight, they assigned it also to integer, the same type. When they took name, they assigned it as string, just like here. So I presume that we cannot change the type of the specific field. Let's try that. Let's grab it. All right, we'll save it. It's all good. We'll run it. We have, yep, exactly what I expect. But what if instead of Apple, I want to assign 123? Save it. There it is. Got an integer, but expected a string. So the types, they stay the same. Okay, makes sense. Makes them behave like tuples and all the statically typed languages that I know of. Okay, and we already got 2 exercises. Wow, that was fast. Exercise number 1. Create an empty array which can contain 10 integers. Fill that array with numbers. So be basically whatever times 10. Print only the elements of that array that are in odd indices. And multiply elements on even indices by 5. Print the modified array. Okay, so we want the modified array, so we know that when we create it, it will be a variable. It won't be a let or something else. And this will also allow us to check if really it's that strict about following with what is a let, what is a var, what is const. So we do var, and let's call it numbers. Okay. I will say that it's of type array. It will contain 10 integers, and we have that defined. Okay. Next, fill that array with numbers 10, 20, 100. Yeah, they give us a hand use loops, so we should do 4, and we want a number that we want to add for number in, and I think there was count up, right? Count up. We want to do from 10 to 100 with increases of 10 or something like that, I recall. Our language server died, so I guess we don't have hints, but we'll see. And now it will be like, okay, how do we assign those to the numbers? Because usually we need to do numbers. It's an array, so we need this index, right? And they say that's the number. But the for loops we learn, we can just say, hey, our index, comma number, and the first thing will be the index, so it'll be 0, 1, 2, 3, and this should be the number. So this should work in theory. So let's just do echo numbers. Let's actually do it once again. Oh, doesn't like it. Wrong number of variables. Does it need to be in parentheses? Okay. Okay, that's new. I didn't expect that to happen. So let's go back to our tutorial and see what we missed. We're in loops, for loops, right? We go to from here to here. We had count up and count down. We get the word. If we also need to have iteration counter starting from 0, we can achieve that by using for, counter variable, loop variable, and an iterator. We're practical. So that's what we're doing. For something, index, comma, letter, in word. Okay, I think I see what's going on. So this isn't happy. What if I'm gonna do, instead of count up, I'll just do from 0 to 10, save it, still not happy. I would say hello, save. Now it can go through that. Okay. There's something weird going on here. We can get index when running through a string, but not when we're going through a range or the results of a count up. So what if I'm gonna, because the very quick way to do that would be, okay, screw the index. I'll just do the index, right? We're gonna say we go from 0 to 10. I mean, we need to skip the 10th number, but we know that will be 10 elements. And then the number will be basically the index plus 1 times 10. We save that, we should get a result, right? So let's run it. We started with an array of zeros, so I guess it defined default values, and for integer, the default value is basically a 0, and then we assign those values that we wanted. So this is all good in this case. The code is simple. But what if this whole calculation here is a little bit more complicated? Maybe it's not just, the index times 10. Maybe you want to go over something more complex. So what if instead we're going to do something like values and we'll get that count up that we wanted. I presume this will return a sequence. So let's do echo values and we'll do let because we won't be changing it, right? And let symbol requires initialization. I thought that's what I'm doing here. Expression has no type or is ambiguous. Huh, what is going on here? Let me just try to run it and see if this is just some stuff. Nope. Attempting to call routine count up. It's found from A, B, and then step. Iterator declared in there. So it's an iterator, but it doesn't really work, right? There's no type. Type integer, save. Ah, look at that. That worked. So this is something that I would expect because I know about the concept of generics, and we saw that we were calling that new sequence procedure by specifying integers. So I figured, hey, this might be the same thing. And what is values now? It didn't run. Let's clear that and try to run it again. Error proc has no result symbol. No, okay, I see. So I guess this whole count up is some kind of internal shortcut that can be used only within the for loop. So we can't do anything fancy. Okay, I see. Too bad. Because I hope that we will be able to, do something fancy. But let's try to do it different way. So let's say that we get a variable, values, and this will be an empty sequence, but we need to say that it's a sequence of integers, right? We said it's empty sequence, so I guess we can just skip that. All right. And what we can do is basically do the for loop, and we go index in, and we go from 1 to 10. All right. And therefore we can say values dot add. So we will add that index times 10. And what we should end up here is basically, let me echo values. Let's get rid of this echo to not do that. So first thing we should see is our values that we want to have. And what just happened? Values don't like being specified as a type mismatch. Oh, right. When we specify type, we need to say it's a sequence. There you go. So now this should be basically numbers 10, 20, up to 100. So when we run it, not this shortcut, that shortcut. We have a sequence of those numbers, right? But we need to add them to... So let's pretend that this is some complex situation where we created... bunch of values. We got it from somewhere. It could be anything, right? Could be random, could be read from a file or something. We just have values that we want to add to set to the numbers. So what we could do is for index, comma value in values. Can we do that? Yes, we can. So we can take a sequence, and when we iterate with a for loop, if we iterate over the values, we can get both index and value. Therefore, we can say index is the value. Save it and run it. Yes, so we assigned it properly now. Okay, that works. But what if those values might be longer or something? What if there's more? So let's say that make a sequence from 1 to 20, right? And we'll do echo, we'll do values, and we print values. At the end will be the numbers. Now when we just print it quickly, what do? Oh, now it's unhappy because our values are from all the way that much. While we're iterating over them, suddenly we got to the point where index is larger than what numbers can contain. Unhandled exception. Index 10 is not in 0 to 9 that was in here, because numbers is only from 0 to 9. We just find there's 10 of them. Too bad it doesn't say a little bit more that, hey, this is, I don't know, index out of bounds of variable numbers. That would be a little bit more helpful. But oh well, I guess it's something you can get used to. Okay, so what if instead of doing this, we'll do for, and it'll be the number in numbers. Can we do that? When we iterate over the numbers and we do number is 5? Is that possible? No, we can't do that. Okay, number is just we can't assign like that. Okay, makes sense. So what we can do here is index, comma number, and then we go numbers dot index is 5. So now we'll be able to assign all the elements of the array, right? So when we run it, we assign those. Cool. So now to go a little bit further, to make it a little bit more error prone, we can say if index is larger or equal to the length of two values, the length, right? Because we could get length of the sequence. So if we have a situation where the numbers array has more elements than values, we can basically say break, because we don't have more numbers to assign. And this way we protect ourselves from a situation where, let's say, our values are only, I know we have 3 values in there, right? Let me clear that and we run it. So our values is 10, 20, 30. And if we want to assign them over numbers, when we are iterating over numbers, we'll suddenly go with like 1, 2, 3, and more. So in this case, I only assigned first 3 values because then we didn't have more. In this case, we need to say that the whatever's under that index numbers will be values in the same index. I know that I'm going way off the track for that exercise, but I'm exploring. I'm doing what I like in this case. So yeah, this way we protect against this situation where there are more numbers than the values to assign. And of course, if we have the opposite situation where we have a lot of values, this iterates only over what we have in numbers, so we will never exceed it. So now when we run this, even though we have tons of values, we'll just go over whatever's here and we have the result that we want. Okay, so that was like 30 ways to solve this problem. We can go on to the next exercise. We're in containers exercises. Number 2, let's just copy it and paste here so that we can work at it. Okay, let's get rid of this code. We don't need it anymore. Now, redo the callouts conjecture exercise, but this time instead of printing each step, add it to a sequence. Pick a starting number. Interesting choices, among others, are 9, 19, 25, 27. Create a sequence whose only member is that starting number. Using the same logic as before, keep adding elements to the sequence until you reach 1. Print the length of the sequence and the sequence itself. Okay, so before I go and check the rules for how to create that sequence, we want to have a sequence that we add those numbers to. So let's declare it var, and this will be the result, right? And this will be a new sequence where we put our starting number. So let's also do constant starting number, and we do 9. Okay, so we have our sequence that contains just the starting number, and then what we'll need to do is there'll be loop to add elements. Okay, and after we add all the elements, when we reach the 1 finally, we need to print the length of the sequence. So we'll do echo to result length, and we'll do the result.len. This should give us the length. And then we print the sequence itself. For now, let's just do echo, and then it will be results, and we'll print just the results. I assume that nim will print it however it wants, but I think we'll be able to do it like with the things that we learned so far in the tutorial. We'll be able to, get to the point where we print them out in a little bit more manner. Like, we started with 9 and we have this nice arrow and do something and this and something. I'm sure there are some built-in functions just for that, but we'll build it our way. Alrighty. So in an earlier tutorial, we had probably in loops, we had an exercise, callouts conjecture. So first pick a number. We already did that. If it's odd, multiply it by 3 and add 1. If it's even, divide it by 2. Repeat until you arrive at 1. So let's copy it and we'll just have it here. So, okay. So we can do a while loop, right? And we can check while the result and the last element, of our results isn't 1, we'll do our thing. So if it's odd, multiply it by 3. So let's just do let odd equals, again, we're operating on the last number, right? So let's say that the let last number is the result, and we take the last entry there. So let's say is odd will be last number mod 2 equals, if it's odd, that means it won't be divisible by 2, so the remainder will be 1. And if is odd, multiply it by 3 and add 1. So that means that, we need to already start storing the next number. So let's do variable because it will be changing next number, and that'll be our integer. Nothing crazy here, right? But we can take advantage of the fact that, right now we said it's an integer. We might be changing into something completely different at some point. So we can kind of steal the type from here by saying that the next number is basically the last number, right? Because this will suddenly figure out, hey, so this is an integer. And this will be, if we'll change it into some different type in the future, a float or something, it will make more of our code work on its own. All right, so next, if it's odd, we basically do the next number equals next number times 3 and plus 1. And again, I'll just add this parentheses just to make things explicitly clear. So if it's not odd, right, else, we did that. If it's even, divided by 2. So we do next number equals next number divided by 2. And again, we'll use division here because we're operating on integers. So we need to stay within integers. And repeat this procedure until you arrive at 1, which is this check here. So what we need to do is after we calculated the next number, we need to add it to our results. Result.add, and we add our next number. And this should basically take care of our sequence, and we can print it out. So let's try to run it and see. Oh, it already doesn't let us. Expected. Oh, of course, we need the colon here. Save and run. We've got results length. We've got 9, 28, and so on until we arrived at 1. Perfect. Worked the first time. It's a good feeling, especially in a language that you're just starting to learn. Cool. So I'll assume this is understandable, although I want to try one thing, because we created this variable here. We just assigned it some kind of number, and then if this, we set it to something else, we set it to something. So we have that repeated thing that in both cases, no matter what case, we just assign it something calculated. So what if I'll say that equals, and we do if is odd, it will be the value of the, instead of next number, it will be just last number, because it's the same, right? Last number times 3 plus 1. And then we do else, and we have last number divided by 2. Save. And that should work because this is the equivalent of the ternary expression. And this way we just remove several lines because it's, this algorithm is so simple. Okay, let's go a little bit more extreme. We just take this, put it here, and that should be it, right? Save. So this is starting to look very strange because we add, and inside of parentheses, we have this if, else. But hey, it compiles. Let's push it a little further. We had this last number here, and we calculate is odd, but we use it only here. Let's put it here. Bam. Oh, this is getting real ugly. Okay, can we push it more? Not really, because this last number is used everywhere. It will be pointless to just access it 3 times. Okay, sure. Let's run it. Still completes the same way. Awesome. So now what we wanted to do is instead of printing it as literally a sequence, this is nim printing for us, we want to print it in a nicer way. So format as whatever, 1 goes to 2 goes to 3. So we can do that by creating a string, right? So let's do variable, because strings are mutable, we can just keep adding to them. This will be the result string, right? And we define it, right? This is an empty string. And then we can do for result value in result. So iterate over all the entries, and we'll just keep going, right? Yeah, I'll fix one problem when we get to it. So let's start it. The first thing that we're doing is basically at some point we need to go to result string.add, and it will be, we add the actual result value, right? We'll add it there. Although I don't know, it will be probably unhappy about something. Because one is string, add result string, result value. Yeah, I guess it doesn't like the fact that we're trying to add an integer here. So I'll cheat a little bit. And I know that if I'll add $sign in front of the value, it should turn it into a string. Okay, that works. Good. So if we'll do that, we'll just end up with something real ugly. So we'll have results, and at the end we'll do radiative results. And this will be the result string, so we can compare. So if we're gonna run it, we see that it just added everything together with no space in between, nothing. So let's do it that way. After we add some element, we also add another thing. Result string dot add, and we'll literally add a string space and this little arrow and space, as in space for next element. So when I save that and run it, okay, that looks better. But we have that situation where I have the arrow at the end. So my solution to that would be, hey, let's move it before, right? So when we run it again, we have that arrow up here. And suddenly what we can do is, hey, how about we take that first element of the array, right? And just put it here instantly. So we don't need to do anything. We'll just say, hey, the first element of array, so it will be result and 0, right? This is the first element. We just assign it initial as a value and make sure it's a string. And then instead of iterating over the whole result, we can, again, use the thing that we learned. Instead of starting from 0 to the end, we just do 1 all the way. And let's try to the last element. I hope it works. Let's run it. And looks like it works. We have first element, and then it just continues. That is awesome. Okay, I like that. So we just get rid of this printout, and I suggest the value 19. I wonder what that is going to show. Yeah, just long sequences. Okay, that was easy. We learned a little bit about how to handle and not handle those things. So let's continue. Third and last, find a number in range from 2 to 100, which will produce the longest callouts sequence. For each number in the given range, calculate its callout sequence. If the length of current sequence is longer than previous record, save the current length and the starting number as new record. You can use the tuple, longest length, starting number, or two separate variables. Okay, print the starting number, which gives the longest sequence and its length. Sure, let's copy the thing and we'll be able to reuse our code. So at least that's something. So basically we have a range of numbers, so we'll need to iterate over them. So, I see, this will be real simple. All right, so let's start going in a way that we'll have the starting number, but let's do it this way. We'll do 4 and starting number in, and we have the range from 2 to 100. Okay, and we can indent everything. And our starting number is already declared here. Just get our results. We just do all this stuff. We basically calculate the whole thing, and we have the length. Okay. And we don't need formatting it anymore. I'll just put it away from later. So we can actually print out for which number what the length is for now. So 4, and we do starting number is, and we have the length of the result. Okay. And if we'll just have a loop like that, we're just gonna loop over all of them. Let's just ignore all that and see what happens when we run it. Okay, for 2 is that, not that, and it just continues. We can see that for 7 it was nice length, etc., etc., etc. Oh, for 27 it's 112 steps. Wow, that's a lot. And it went like that for the whole thing. That is awesome. So we can just iterate over them. So now all we need to do is basically the record, which will produce the longest. Calculate the callout sequence. We did that. If the length of current sequence is longer than the previous record, yeah, so basically override new record. So longest length and starting number, that's what we need to track. I won't bother with a tuple because it's kind of pointless here. So what we're gonna do is we have a var max length, and we do, of course, start from 0 and var record starting number. And we start with 0 because, whatever. So when we go to the length, right, instead of just printing it, we can say that length is the result len. So we have it as a variable. And then we can say if length is larger than the max length. So if it's a record, then we say max length is the new length. And then we also do the record start number is the starting number. And that should be it. And the end, we just say echo the largest, then the starting number, do the record starting number, sequence of, and we put the max length, values. This will print it out nicely. Okay, so when we clear it and run it again, we have the starting number 97 made a sequence of 119 characters. Awesome. So that means that we can suddenly lift it up to, I don't know, 10,000, run it, and invalid indentation. What happened? Where? Oh, now it worked. Okay. The starting number 6,171 made a sequence of 262 values. Perfect. Easy peasy. So we just finished sequences all the containers. And I'd say this was an interesting chapter. I'm sure there are more different types of containers because, this can't be all really, seriously. But I'm really happy to see tuples because that means that, it's easy to return multiple values from, I guess, procedures. Therefore, you don't need to do shenanigans with references and whatnot. That means that you can probably define them as types and reuse them because you can name some of the values inside tuples. That means you can also use them as little temporary objects instead of, declaring specific type somewhere or whatever. You just do on a go. And in C# that will be an equivalent of a anonymous object. So yeah, I like it. I like the difference between a sequence and an array. They are pretty powerful already on their own. So yeah,